So hello everyone, this is the example for the final part of the chapter. The question says that determine the greatest acceleration, the maximum acceleration of the car. So we have two conditions. The one is that the front tires do not leave the ground. Okay, the maximum A, either so front tires then we have stated or tires slip on the track. The coefficients are for friction are the 0.8 and then 0.6. Neglect the mass of the tires. The car has a rear wheel drive and then front tires are free to roll. So first let's start with the free body diagram. So we have the weight of the car. We have the normal force at the rear wheels. We have normal force at the front wheels. Okay, and then we have a friction force. So the friction force will be that, this is the rear wheel and it rotates that way because the car moves this way. And then the friction is against the motion and that's the F of F. So we have a frictional force this way. Yeah. So we don't consider the frictional forces on the front wheel. Okay, we don't consider. And then these are the forces that we have. We will use the Newton's second law for a rigid body. We will use the first equation. And then actually you can use any of them, but the first one looks easier. So let's start one by one. The first equation is that we have the forces. Let me see, I have space here. So we have the forces acting in x direction is equal to MAG into x. In x direction forces we have negative. Let's choose the x direction actually. This is the x and that's the y. Negative F of F. And then we have that will be equal to negative MAGX. And then this is the first part. The second part is that the F of y is equal to MAGY, and then there is no acceleration in the y direction, that's 0. So we have n of a, which is positive, n of b, which is positive, and then minus w, which is negative, that's equal to 0. Okay, as you can notice that we have one unknown here. The second, let me just show the unknowns. So one unknown, the second unknown, third unknown, we have one more unknown, 4 unknowns. We have 4 unknowns, but 2 equations, but we have conditions here that either front wheels do not leave the ground or the slip of the tires. We will use either of these conditions to decrease the number of unknowns. Okay, then we have the moment equation about point G. the moment equation about point G, that will be Ig into alpha. Okay, so if you look at the car doesn't rotate. Okay, and then the wheels rotate. And the question says that neglect the mass of the tires. So we know that Ig of wheel is m into r squared, proportional to actually. And then since m is 0, then this quantity will be 0. That's the reason that the moments about G will be equal to 0. And then if you do that, we have moment about point G created by n of A times the arm of n of A is 1.82. And this one rotates car in that direction, which is a clockwise direction. That's the reason it is negative. Then we have n of B, which rotates the car in this direction, which is counterclockwise. The arm of n of B is that 2.20 minus 1.82. Okay, this part is the arm. And then frictional force that tries to rotate the car again in clockwise direction. And this clockwise moment of the frictional force has an arm of 0.55 about point G. That's equal to 0. This one is that way and this one is this way. So we have 1, 2, and then 3. But these have been defined before. So we have one equation and then 0 unknown. Okay, so with this in mind, let me write all equations together. The first equation was f of f m a g x. The second is that n of a plus n of b minus w is 0. The third equation is this one, n of a negative times 1.82 plus n of b times, this one makes 18, 0.38 minus f of f 0.55 is equal to 0. Okay, these are the equations. We have one. Let me show the unknowns here. So unknown, we don't know it. And then let me see if we have anything else. So we have 4 unknowns, but 3 equations. Now let's go back to conditions. The first thing is that it should either front tires don't leave the ground. Okay, so let's assume that are about to leave. Okay, so on the verge of. It has not left the ground, but it is not on the ground. It's almost. Okay, in that case, if you do this one, then you will have that n of a is equal to 0. Okay, it is on the verge. It has not left, but it is not on the ground. It is just almost. So in that case, we will have the equations of f of f is m a g x. Then n of a will be 0. NB minus a W will be 0, and this one is 0. The last thing is that N of A 1.82 times N of B times 0.38 minus F of F times 0.55, that's equal to 0. And then here, this one is also 0. From here it follows that N of B is W, and then W is the mass into the gravitational acceleration. Okay, then from here it follows that okay, 9564 that is the NB. We know NB, and then we can find the F of F. So from here times divide by, okay, so in that case 0.8. That is F of F, and then acceleration will be that 6.8 meter per second squared. Okay, that is the equations and then result for the first part.